Okay, now the problem 7.41. Suppose x1 follows the binomial distribution with a1 theta as the parameters. X2 is also binomial with n2 theta as the parameters, and they're independent. Question is to show that y, which is the sum of the two guys, is also binomial with n1 plus n2 as the parameter, and theta as the parameter. And which the question asks us to use the MGF technique. Using the MGF technique. So the moment generating function technique says that. So first recall that the moment generating function of x, the binomial random variable, x is this, right? So it's a function of t. T is a number between around 0. So it's 1 minus theta plus theta times e to the t altogether to the power n. So that means the x1, x2, they have this form of moment generating functions, right? Just have different theta here. Theta is the same for both of these two guys. That's very important. They have to have the same theta. Okay, now because they're independent, we know that the moment generating function over their sum is just the product of their moment generating function, their individual moment generating functions. So that's why the my is just equal to the mx1 times mx2. The mx1 is this guy, right? And the mx2 is this guy. And you can see that they are all the same except that they have different exponent. So multiplying them together is just giving you this guy here with the sum of their exponents, which is a n1 plus n2. So by comparing this guy and this guy, you can see that everything stays the same except that the power here is n1 plus n2. That just means that the y is a binomial random variable with n1 plus n2 as the theta as the parameters. Okay, so that's how we got the distribution of y. Actually, you know that when you have two random variables x1, x2, like in this way, the x1 following binomial n1 theta is just it's a number of successes. When you toss, for example, you have a coin with a probability theta of getting a head and the 1 minus theta of getting a tail. And you toss that coin for n1 times. And x1 represents the number of heads you will get, okay, which is random. It's number is a random number, or it's a random variable. And x2 is the number of heads you will get by tossing the coin for n2 times. So if these two things are independent, the sum of them is just the number of heads you're going to get by tossing the coin for n1 plus n2 times. So that's why y is just this distribution.